Hey guys, so just a quick introduction into week 3. This week obviously we're still in the same shot, but we're moving on to our magical shield effect. And much like the portal, some of the same basic workflows we'll also use in the shield itself. Hey guys, so just a quick introduction into week 3. This week, obviously, we're still in the same shot, but we're moving on to our magical shield effect. And much like the portal, some of the same basic workflows we'll also use in the shield itself. So we'll also be starting with some volumetrics and particle advection. But before we get there, in week 3, we'll tackle some of the more procedural elements to managing this effect, so making sure that the shield is where it needs to be at all times. So that's completely procedural and based off of the character's animation. We also have random impact points from projectiles, which will be completely procedural as well. And so those first few videos will form the basis of the rest of the effect in terms of timing and location. And then, as I said, we use some of the same techniques. So we do a basic volume sim, but it will be slightly more advanced than you saw in the portal. And we also do a little bit more advanced work on the advection front of the particles. Not only that, but before the end of week 3, we'll be doing a bunch more SOP-based tweaks and changes to the particle sims as well, messing around with color, and we might even start looking at a few of the more sci-fi and less naturalistic elements. But for the most part, it's all about proceduralism and delving a little bit deeper into the volume and particle simulations themselves, and really experimenting with some post-simulation workflows as well. So I hope you guys enjoy it, and I'll see you soon. Hello, welcome to week 3. So we finished the portal for now at least, and it's time to move on to the second effect in that shot. So if I just jump back to the original preview, so we've got something for that, and now we're moving on to the magical shield. So a few thoughts going into this is, obviously I want it to feel magical, but also slightly sci-fi. So we'll try and introduce some geometric patterns in there as well. And on top of that, I've just been looking through some reference, so I'll go through what I've found and then discuss some other things we'll want to add. So I'm just looking at Magic Shield here on ArtStation. A couple of cool things. Not exactly, I mean, this is like that kind of thing is just too simple. Like, it can work really well having a really simple effect like that, but obviously to make this class a little bit more interesting, we're going to try and add a bunch of detail. So let's try force field. So like in some cases you can definitely get a great result, there's not much on here, by going very simple, and it's often actually better. But we're just going to add as much detail as possible, and then obviously if you work on your own or you do it as a job, just keep in mind that simpler is sometimes better. That's very cool. I mean, Pinterest is really the way to go. So many cool concept art. That's really nice as well. So this is an example of not even having an effect to represent the force field itself, but just relying on all the effects around the field, which is really awesome. And I have an example of that from X-Men over here, so I'll show you that after this. But basically I've started saving a couple of these into a folder, and every now and again I'll just come back to Pinterest and search for Magic Shield and see if there's anything else I can get inspiration from. That one's quite nice. So what I want pretty much is something very magical. So we'll go for advected particles again on the inside of the shield, and then an extra element that introduces the geometric patterns onto maybe the surface or onto the inside as well, something like this. So we need to make sure we try and make it feel sci-fi. If you guys want to go 100% fantasy, then obviously you try and introduce organic shapes, organic patterns, or just leave it as the internal advected points, because that's going to feel the most fantasy. And then as an example, over here, I'll be using this as reference as well. This is the final scene from X-Men Apocalypse, and this villain has a magic shield, and like the other reference we saw, it doesn't actually, it's invisible, but you see the weapons and the ground and the bullet impacts and everything interacting with it. So I think that looks really cool. You're just seeing the fire from the impacts and all the smoke. So I'll probably be looking at this, trying to recreate some of that kind of effect, and then also just going over the top with the internal details. So that's where I'm at. I'll try and save some of these to a folder, get some more inspiration, and if you're following along with me, it would be really beneficial for you if you picked out some images you liked and tried to stick to that reference instead of recreating the same looking effect I'm doing. So if you go through, so that's why I'm not showing you exactly the ones I'm collecting into a folder, but just more of an inspiration type of thing. And if you pick something like this, and I go down a particular route, you should try and incorporate these hexagons into yours instead of doing whatever I end up doing, which might be hexagons. So with that, we'll jump back into the scene we used to make the portal, and we'll just keep adding more geonodes and start working on the magic shield. So I'll see you in the next video. Hi. So we're going to jump straight in here and do the basic semi-procedural setup for the shield. So let me just put down a new geo. Effect shield. So what I have is, let me just change our frame range. The whole shot is 220 frames. So now we need to do this until the end of the shot, and we'll start at frame 100. I know the shield, the portal stops at frame 130, although technically we've keyed it in a way that it ends sooner. But he starts running from 100, so it's a good place to start. And the shield opens between 120 and 124 basically. So I do have this layout sphere, but this I just hand placed. So there's nothing going on in here except some keys on a transform. So what I want to do is remake that procedurally, and we'll get that opening and moving with the character first before we move on to the rest of the effects. So I'll probably save the rest for videos after this one, but we'll do the basic setup here. Hopefully it won't take too long. So all we need is a basic sphere I'm going to recreate instead of taking the one I've got. I want this to be at the origin for the same reasons we work with the portal, as it might make our life easier. So we have this sphere. Let me roughly base the scale here. So something like that looks pretty good. So that's all we need. And then what we need to do is, I'm just going to add a point at the origin, and I'll object merge the character into here. So there's our character, here's our point, and I'll just set the point's position to the center of the character. If I can spell properly. Okay, so that's our point, basically stuck to the middle of this character here. And then I'll basically just copy this sphere onto that point. Now, I could have done this, I could have basically just based the position of the sphere on the centroid of the character. But I prefer to keep this separate. In this way, I've got one chain that's managing my overall location, and then I can have a bunch of other stuff I can do here that's not reliant on the position of this. So I'll probably put down, like, make sure I have a rest position if I need to do UVs later, or add some deformations, something like that. I can do it here instead of worrying about the fact that I've based the position. I could always put a transform later on, but there might be benefits to keeping a completely separate chain. So this works for me for now anyway. All I need to do is copy that on. And that's fine. So let's have a look through the camera. So a few things I'm noticing here. Well, let's actually first key a transform. So we'll just make sure it's opening, even if it's just for visualizing. So we set from 120 to about 124. And we don't need to do anything particularly special with this animation. It just needs to feel snappy. So we just want that shield to pop on, not take too long. Something like that. Feels slightly early, but I'll leave it for now. And the other thing I'm noticing is, because we're attaching the sphere to the centroid, that character's sort of moving up and down a little bit. So the shield itself is sort of bobbing up and down. So I don't want that. I'm going to lock off the Y position. So you could use a wrangle. I'm just going to use a VOP here. And I'm going to choose a stable time. So in this case, probably just when the sphere is fully opened. So once it's opened at 124, I don't want the Y position to be changing with the character. So I just lock this off. And in the VOP here, I'll take P. And if you guys are used to using wrangles, then that's fine. Just do it in a wrangle. I would say that it might be beneficial every now and again just to dive into a VOP. Experimenting is a little bit easier in a VOP, and also it's just about overall concepts. So just learning how to think about the stuff that you can do in Houdini procedurally, or how to think about some of the more complex effects. It can be useful to do that here through sort of like visualizing conceptually what you're doing instead of just writing code in a wrangle. So if you're completely comfortable in a wrangle, that's great, but I would suggest every now and again just experimenting with a VOP. It can be really good. Just to think through the effects that you're working on. So in this case, I'm taking the, what do I want? Import point attribute. So basically, I'm keeping the X and Z position, and I'm replacing the Y position with the Y position of the static point. Where is this? So that should do that. So I mean, it's bobbing up and down very subtly, but this is now keeping a perfect position on Y. So that looks good. Just double check our positioning here. So we can always change that later. For now, let's keep going. What I'm going to do is actually flatten this. Flatten the bottom so it looks like it's interacting with the floor somewhat. So we'll do the same thing we've been doing a bunch before. We say if the Y position is less than 0, then equals 0. So we'll just squash the bottom like that, and then I'm going to subdivide afterwards, because it looks nice when there's some sort of a little bit of rounding here. So, and if I reduce the amount of points in the original sphere, I can exaggerate that smoothing. So we don't want it too much, that's probably fine. Looks kind of soft, but it's cool. So we have that. And this is perfect, because now if the animation team decide to change the animation of the character, we have a sphere that automatically will adjust to the new position. So let's have a look at how this looks. So I have keyed it growing from 0 to 1, but I'm not shrinking it back down, because I actually want the effects just to dissipate. So we will see how the shield sort of blinks out of existence, but just through all the effects we have just dissipating instead of shrinking. So there we go. That's our basic sphere we'll be using for the rest of the effects. So I'll probably go and write this out and then we'll carry on in the next video. So this was just a quick one to get our base set up. And now we're ready to get started with the effects. So I'll see you in the next video. Hi, so just to describe a little bit of what I'm trying to do is basically this sphere here is moving now, and I want to lock it off at some point to do the rest of the effects. And my plan with that is we have some projectiles coming into the room, hitting the shield, and those impact points will be the source of all the effects afterwards. So basically, as soon as a projectile hits the shield, that becomes a source for the volume sim, for the particle sims, and everything else, even for the base advector volume sim. So we will be emitting volume into here, and I need that source to be every time a point hits. So my idea with that is just to scatter points randomly on the surface every frame, and then use those points to drive every source after that. So what I'm doing here is I've just put down a point SOP to set some point normals, and I'm going to write that out. It's nice and quick. And then we'll move on to the scattering of the points to use as our source. So there we have it. So at the moment this is still moving, which is fine for now. So let's put down a scatter. And I only need this to well, let me put $F in the global seed. So every single frame we get a new impact point. That's a bit much. So something like that. So this sphere will be essentially getting hit by hundreds of bullet impacts. And then I just want to remove any that aren't facing in this direction based on that normal. So the room, we're looking down in the z-axis, so I can just set, so let's just scatter some more. I'll just put down a delete here. Delete points. That are positive on Z. Oh, no, negative. And then even more. So we need any Z normal less than 0.5 will be removed. So we're only keeping these ones that are pretty much facing in that direction. So those can be our impact points. So here I'm gonna just emit a particle for each one. So basically what I want is as usual, and I think I did this with the portal as well, it's basically, I need a point to exist that has age and has whatever attributes that usually come with a pop that give me a lot more control. I could just generate my own attribute for age, but I mean, if I don't need the points to move, then I can just use a pop net. So we'll just use all those points. We don't need any velocity. And I want them to exist for exactly 2 frames. My thought process for that is when we go on to do the projectiles, I can actually use these pops and copy a line, and all you need is two frames, basically a frame here of a projectile and then impact frame, and that sells the complete contact. So we'll probably tackle that still a few more videos down the line. But for now, I know I basically need my life to be 2 frames. So 2 divided by 24. So this helps as well for our sourcing. I can't just have a point existing for a frame. It helps to have, where are they? It helps to have them come into existence and then at least last for one more frame to source the volume or the pops or whatever before they disappear. And it also gives us range on a ramp if we're using age. So that's our basic impact pop. I'm just gonna save. And now what do we need? So I need to basically, I'm going to use another copy, and I'm going to copy a small sphere on here. So something to really easily represent our sourcing, and I can actually use the normals from those as well for velocity. So let's just try some stuff. So I am going to, actually I've just thought I need to get rid of the start here and the end. We might as well do it here before the pop. So I'm just going to use a switch and a null. So we'll say let me just get my timings right. So he starts relaxing around there, so let's say 163. So after 163, it will switch to the null, and then before 124. So if we end up adding some other gunfire or projectiles around the environment, we can do that in a separate network somewhere. But for the sources for the magic effect, we just need it to appear at the time the shield appears. So, and I always forget this. So $F less than 124, and then it's either and or. So if it's less than 124, then it's the null. Then it switches back to the points. And then after 163, it switches back to the null. So that's basically our sourcing range set. So we can copy and paste this and use it wherever else we need the shield to appear or disappear. So I'm going to use that now and just take the actual shield as well. So this is not necessarily to be rendered, but to use as collision objects or sources. We have everything based off of this timing. So I have these spheres now, and I basically want to lock this off at this point and move it back to the origin. Something to just double check, if these points are existing for more than one frame, then they'll actually be slightly offset. You see there, because they left behind while the portal is moving back. So I'm also going to array these points onto the moving sphere. Just to be sure. And then here I'll just do $CEX, CEY, CEZ times -1. Oh, we don't want that. No, I need to use the centroid of the actual sphere. So let's use this. I don't want that because that's putting the centroid of the sources, but I need them to be relative in space to the size of the sphere. So we'll do centroid like that. And this is because I'm using the centroid of the animated sphere. So I'm going to use this one instead. Well, that's not fixing the problem. Oh no, it is. Yeah, that works. And I'm actually just going to copy and paste this. So there we go. Hold on, I still have an issue here. So actually I have these points existing too early. Why is that? They should be gone. Maybe I just haven't refreshed the PopNet. There we go. So there is no source before 124. So I could actually switch this back to the moving version. The one without the sourcing, but this is fine. So let's double check that again. So we have the shield at the origin, and we have the source spheres there as well. Okay, and now let's scatter a bunch of points on this shield. And you know I'm going to use an attribute transfer. So let's just go with a bunch. And I'll set that to black. And these ones to white. And I'm going to set a velocity. I want color and velocity to be transferred, and then we can just keep the white points and they'll have input velocity that we can use as our volume sim source. So here we've got these normals. So we'll set velocity to n. So something like that. Something else I might want to do is scale these up. So this is it's either a long or a short process, just depending on how much you want to experiment. I'm kind of changing direction constantly and thinking of extra things to change or try on the fly. So it does take me a while if I'm if I have enough time to experiment with different thought processes that come up. So I don't want to spend too long just going off track. I'll just do this one quickly, and then if I think of something else, I might just keep it to myself until I decide to actually try it. So in this case, I'm going to use that age attribute we were talking about to scale the spheres. So the points only exist for 2 frames. Oh, I need to use template point attributes. So I should have an age here, and I'm just trying to use the age to drive the size of the spheres. Which doesn't seem to be working. They're there. Yeah, that works. So we'll get the first frame of the source will be small, and then suddenly big, and then disappear. And we have a velocity. We don't want to take the velocity from the point cloud here. Now that's weird. This should just be based off the normal of the spheres. Ah, okay, so I shouldn't have been using this. So I don't need age after this point, although I think I might. So I'm actually just going to take age and life. And I'll leave everything else so I get my nice normals. And we'll attribute transfer this. So let's see what we've got. All I need is color and velocity for now. And we'll just blend that a little bit there. So that gives me something to work with, and if I check the velocity, I get a little sort of spread out pattern from those spheres. So that's the benefit of copying spheres onto those points. I'll just increase the resolution there. See, I'm just max sample count. I'll go up to get a more averaged copy transfer there. So that's good, that's working, and I'll delete everything except the white points. There you go. So that's a pretty reliable, pretty procedural source. And anything we do in terms of adding the projectiles in the environment will match up perfectly in timing and in position with these sources. So I'm pretty happy with that. So we've got a moving sphere and we've got sources based on some pops. And they already have some velocity to work with. So I think after this we'll just add some noise to that velocity and set up a smoke sim. So our basic volume sim that we'll use for advection. So I'll catch you in the next video.